If the kinetic energy of the particle is increased to 16 times of its previous value, the percentage change in the de Broglie wavelength of the particle is. Okay. So let us assume the initial de Broglie wavelength B, that is lambda naught, which is equal to h divided by m into V. If the kinetic energy is increased by 16 times, then the kinetic energy initially it is normal and increased is Ke dash, kinetic energy dash representation, which is equal to 16 times Ke original, that is initial. This implies the kinetic energy it is half into mv square, and once it is increases 16 into half m v naught square, then here v is equal to 4 times v naught. Thus, the new de Broglie wavelength is, that is lambda is equal to h divided by mv. Then we can write it as h divided by m into 4v naught, which is equal to lambda naught divided by 4. Because hmv naught it is there, then lambda naught by divided by 4. Thus, the percentage change in the wavelength is given by change in wavelength. Change in wavelength is given by, that is lambda naught minus lambda divided by lambda naught into 100 percentage. Then we can write this one as lambda naught minus lambda is equal to lambda naught by 4 divided by lambda naught into 100. Then which is equal to 4 minus lambda naught by 4 is nothing but 3 lambda naught by 4 is there. It will go to the denominator. It becomes 4 into lambda naught into 100. Then we can write this one as, this is 100 percentage. 100 percentage is there. Then 100 percentage is nothing but, once again it is 100 is there. Then we can write this one as 75 percentage. 3 by 4 is nothing but 75 percentage. Okay. So option B is the right answer here.